My experiment for surface phenomena, homework number 2, is on the relationship between capillary height and surface tension with change in salt concentration. Capillary rise is due to the pressure difference in and out of the liquid meniscus. For wet in liquid, or in case of water it's hydrophilic, the inside pressure of the meniscus is lower than that of the pressure outside, which is the atmospheric pressure in most of the cases. The shape of the meniscus cannot be said to be spherical if the radius of the capillary tube is large, but if the capillary tube is sufficiently very smaller, you can assume the meniscus to be spherical. And we can obtain two equations for the pressure difference between the meniscus and the outside pressure. First equation is delta P equals delta rho GH. It is derived from the weight of liquid column, which is higher than the surface level of water or the liquid. And then the other equation for delta P is derived considering the surface tension on a meniscus, and we can equate them two to get the equation for the capillary rise, which is 2 gamma cos alpha over delta rho gr, where gamma represents the surface tension of the liquid and alpha is the contact angle of the meniscus with the internal wall of the capillary tube. The rho represents the density and the g represents the gravitational force, and r would be the radius of the capillary tube. The list of materials that I have used in performing this experiment are listed below. I've used capillary tubes of 0.0276 inch internal diameter, which is 0.35 millimeters, and I have used water, common salt, and a meter ruler.
This is the outline of my experimental procedure. Initially, I obtained the capillary height measurement of a water glass. How I did was that I inserted a capillary tube into a glass full of water and measured the rise in the capillary tube with a meter ruler. Then 1 teaspoonful of salt was added to the same glass of water and the capillary height measurement was obtained. Likewise, this process was repeated and I added 1 teaspoonful of salt into it, mixed it well, and took the measurement. Like this was repeated for 9 consecutive times.
So these are the results that I have obtained when I checked the capillary rise with increasing salt concentration. In the table on the left hand side, you would see that the capillary rise, which is given in centimeters, have gone down when I increase the salt concentration. This is not measured in grams. This is a weight measurement because I have used a teaspoon, but we can get the qualitative idea where what happens to the capillary rise with increasing the salt concentration. The graph shows that it reduces when we increase the salt concentration, and we can see that there is a considerable high drop in the beginning compared to the next subsequent decreases, and this implies that like I said before, the capillary height depends on surface tension, and cosine value of the contact angle alpha, density of the liquid rho, gravitational force G, and radius of the capillary tube. And in case of adding salt to the wet water, it changes the density of the mixture as well as the surface tension. And here we observed the net change of capillary height when we increase the salt concentration is negative. That means the capillary height reduces with increasing salt concentration. This could be either due to the lowering of surface tension, which is like surface tension is directly related to the capillary height, and it could either be due to the increasing density of the solution. This concludes my experiment, and have a nice day.